All right, so our learning objective for this lesson is to use given information to convert from grams or moles of one substance to moles or grams of another substance. So we've already learned how to use dimensional analysis to convert between units and to especially convert between moles, grams, and particles of the same substance. Stoichiometry takes it a little further. So stoichiometry is a process that will allow us to convert between units of different substances in a chemical reaction. So it really allows us to calculate the amount of reactants and products in a chemical reaction. Okay, so I think the best way to conceptualize stoichiometry and what it's all about is to make an analogy for you. Many times if you see an introduction to stoichiometry, you will see a relation of stoichiometry to recipes. So the recipe that I'm going to use for my analogy is a bacon double cheeseburger. Now for one of these cheeseburgers, as the ingredients here are listed, I would need 4 slices of bacon, 2 hamburger patties, 1 bun, and 3 slices of cheese. Since I now know how many of each ingredient is in one bacon double cheeseburger, I can actually use this recipe to determine how many of each ingredient I would need if I wanted to make more than one cheeseburger. All right, so let's look at some problems that deal with this. The first problem says how many slices of cheese would you need to make 5 burgers? If I wanted to do dimensional analysis, I could look at my ingredients and make a ratio of the given food ingredient and the wanted food. So the problem tells me that I want 5 bacon double cheeseburgers. Now these 5 burgers in this problem are technically going to be the given information for the problem. So since I have that number with a unit of burgers or bacon double cheeseburgers, that's actually going to be my given. So if I'm going to set it up in dimensional analysis, my given would be 5 bacon double cheeseburgers. All right. My wanted, so what I'm trying to solve for is going to be slices of cheese. So like the number of slices of cheese is going to be my wanted. So here's my given, here's my wanted. Now, we know that to get from your given to your wanted, you need to have a conversion factor. The conversion factor that I would use is going to come from this recipe. So I can make what I like to call an equal statement or a conversion factor from this recipe, because I know that for every 1 bacon double cheeseburger, I'm going to need 3 slices of cheese. Now I can use my conversion factor in the next column of my dimensional analysis. Remember that the whole point of dimensional analysis is to cancel out the units you don't want to get to the unit that you want. So since I have bacon double cheeseburgers up here, my 1 bacon double cheeseburger from my conversion factor or my equal statement has to go on the bottom. And I know that's going to be equal for this recipe to 3 slices of cheese. So my bacon double cheeseburgers would cancel, and then I would get 5 times 3, which is 15 slices of cheese. Okay, so the next one is saying that I have 14 patties. How many slices of bacon, buns, and slices of cheese do I need? Now, for this one, given to me in the problem is my 14 patties, and in order to figure out how many ingredients I need, I'm going to have to figure out how many burgers I can make with 14 patties. So I'm going to do dimensional analysis for this just to get some more practice in. So my 14 patties is going to be my given. All right. And as I said, since we want to figure out how many burgers I can make with 14 patties, burgers are really going to be my wanted substance. So this is going to be my given. And my wanted is going to be how many burgers I can make with that. So I can make a conversion factor between the patties and the burgers using, remember, our ingredients and our recipe here. All right, so I know that one bacon double cheeseburger is going to be equal to 2 patties. All right, now I can use this conversion factor in my dimensional analysis. So since I want my patties to cancel out and I want to figure out how many bacon double cheeseburgers I can get, I would set it up like this. I would do 14 divided by 2, which is 7 bacon double cheeseburgers. All right, so this is really showing how your units are canceling and how you're left with the unit that you want. Now, I can do dimensional analysis for the slices of bacon, buns, and slices of cheese, but to save time, I am just going to basically multiply all of my ingredients by 7. So with the bacon, so I'll just put slices of bacon. I would do 7 times the 4 for my one bacon double cheeseburger, so that would give me 28 slices of bacon. For the hamburger patties, we already know that's going to be 14. For the buns, I need 1 bun, so I'd have 7 times 1, which is 7, so I need 7 buns. And then for slices of cheese, I would need 7 times 3, and that's going to be equal to 21 slices of cheese. Now keep in mind that I got this information from my original recipe. All right, so at this point you might be questioning, okay, why did we do all that work for this recipe analogy? So this is really to show that we needed a recipe to determine how much of each ingredient was needed. And when we talk about stoichiometry problems, our recipe is always going to be a balanced chemical equation. So when we do stoichiometry, just like I look to my recipe in my analogy, I'm going to look to my balanced chemical equation to tell me what the relationship between different substances is. So before I can ever do any stoichiometry problems, I have to have a balanced chemical equation. So recall that stoichiometry is going to allow us to convert units between different substances, which means that there has to be a relationship between these substances in a chemical equation or a chemical reaction. These relationships are what we call mole ratios, and they're going to be used as conversion factors in stoichiometry problems. Okay, so remember when we were balancing equations, we were talking about how these coefficients are going to represent the number of individual atoms or molecules. So if I have this example, N2 plus 3H2 is going to create 2NH3, all right? To balance it, we did a couple diagrams or models. I could say that N2, so if this is an N atom and I have 2 of them, remember that it's a diatomic element, so I only have 1 molecule of this N2. So these are connected, this is 1 molecule. Because I don't have any coefficient here, so that tells me I have 1. All right, my coefficient for H2 is going to be 3. So I have 3 molecules of H2. So here's my 1 H2, here's another one, and here is my third one. So this 3 pertained to 3 molecules of H2. And then my 2 coefficient for NH3 was saying that I had 2 molecules of NH3. So with a particle model, so there's my N, and then I'm going to have 3 H's on it. And then I have 2 of these, so I would draw another one. And with balancing, we kind of said, okay, if we count up all of our atoms, it looks like I have, 6 hydrogens over here, 1, 2, 3, 4, 5, 6, and I have 1, 2, 3, 4, 5, 6 over here. I have 2 nitrogens on this side, I have 2 nitrogens on this side. So everything is balanced because the number of atoms and the kinds of atoms are equal on both sides of our equation. Well, something else that the coefficients can represent is the number of moles in a chemical reaction. So, looking there, I can ask, okay, how many moles of N2 are present? Well, I just look at the coefficient. I know that doesn't have a coefficient, so it tells me that there is 1 mole of N2. With the H2, I have a coefficient of 3, so I have 3 moles of H2. And then with the NH3, I have a coefficient of 2, so I have 2 moles of NH3. So overall, this is going to be my ratio that I'm going to use in problems that deal with this chemical reaction. Okay, so if I give you an example, so here's my mole ratio example. I have a non-balanced chemical equation. First thing I'm going to have to do is balance it. So to balance this chemical equation, split it in half, make sure that the number and kinds of atoms on both sides are equal. So I have 1 Na on this side, 1 Na on this side. Okay, they're balanced right now. On the left side, I have 2 chlorines, but on this side, I only have 1. So I'm going to have to put a 2 coefficient here to make it 2 chlorines. Now my chlorines are good. And that 2, remember, is also going to apply to the Na now. So now I have 2 Nas on the right side. I'm going to have to balance that out on the left side. All right, so now we have a balanced chemical equation. We can talk about mole ratios. So this is saying how many mole ratios can be made from this equation. Okay, so just like the last problem, I can make this big, long ratio of all of the substances in my chemical equation here. But really what I want to do with mole ratios is compare the different substances or find all of the relationships that I can between the substances. So for example, I can say that I have 2 moles of Na and I can compare that to Cl2. So 1 mole of Cl2. I can also say that 2 moles of Na, the ratio to NaCl is 2 to 2. All right, so I compared my Na to my Cl2, I compared my Na to my NaCl. The last thing that I can do is compare my Cl2 to my NaCl, and I know that 1 mole of Cl2 is going to be compared to 2 moles of NaCl. So we have a couple different ratios here. My Na to Cl is going to be a 2 to 1 ratio. Technically, my Na to my NaCl is going to be a 1 to 1 ratio because I can divide both of those by 2. And then my moles of Cl2 to NaCl is going to be a 1 to 2 ratio. I can make conversion factors with these ratios. Basically, all I'm going to do to make that conversion factor is put an equal sign in between it. So I can say that 2 moles with this equation of Na is going to be equal to 1 mole of Cl2. So this is giving me the relationship based on my balanced chemical equation. I can also say that 2 moles of Na is equal to 2 moles of NaCl. Now with my conversion factors, I'm not going to reduce it. I'm just going to leave it 2 to 2. And then last but not least, 1 mole of Cl2 is going to be equal to 2 moles of NaCl. Okay, so from that one balanced chemical equation, we came up with 3 different mole ratio conversion factors. So how do you think you know which mole ratio conversion factor you have to use? To figure out which conversion factor or mole ratio you need to use, you have to look at your problem. So first thing you have to do is determine what is the given substance and what is the wanted substance, which is the substance you're trying to solve for. So looking at this example, it says how many moles of chlorine will be needed to produce 5.4 moles of NaCl. First thing, before I even do anything else, is just to make sure that I have a balanced chemical equation. So here it is given to us, already balanced, so that's good. Then I look at my problem, and the information that's given to me in this problem is 5.4 moles of NaCl. So this tells me that NaCl is going to be my given substance, and then I'm solving for moles of chlorine. So chlorine is going to be my wanted substance. I always like to label these in the problem and also circle them in my balanced chemical equation. So I'm going to circle those 2 things in my balanced chemical equation. All right, so this is going to help me determine that the mole ratio conversion factor I need for this problem is going to compare these two substances. So I can say that 1 mole of Cl2 is equal to 2 moles of NaCl. Please notice how I'm putting units and labels for all things. This is really going to help you with working out problems. You have to have a unit and a label so that you're not getting mixed up and so I can follow your work. So today we're just going to be solving mole-to-mole stoichiometry examples. So based off of that problem from the last slide, I'm going to do that, but I'm actually going to solve for it now. So the last slide, we just found out which conversion factor or mole ratio we're going to use, and now we're going to actually solve the problem. So remember that we were comparing chlorine to NaCl, so I'm just going to circle those here. All right, I knew that 1 mole of Cl2 is going to be equal to 2 moles of NaCl. All right, now I can actually set up my problem in dimensional analysis. So my given is going to go in the upper left-hand corner. 5.4 moles of NaCl. Notice how I'm using my mole abbreviation and I'm also putting the label. Make sure you do this in all of your work. I'm going to be looking for that. This is going to give you points on an assessment. Make sure you practice and then do it correctly on the test or the assessment. All right, so 5.4 moles of NaCl is going to be my given, and then I need to use my mole ratio conversion factor in the next column to get to my wanted substance. So if I have moles of NaCl up here, remember that we want to get rid of that and get to chlorine. So I'm going to have my 2 moles of NaCl from my conversion factor down here so that my moles of NaCl cancel, and then I know that that's equal to 1 mole of Cl2. Okay, so if I type this into a calculator, I'm going to have 5.4 times 1 divided by 2, which is going to give me 2.7. And then the unit that didn't cancel out is going to be my moles of Cl2. My answer has to have a unit and a label, just like all of my numbers did in my work. All right, then I'm just going to double check and make sure that this is what I was solving for. So I'm trying to figure out how many moles of Cl2. I'm left with moles of Cl2. I know I did it right. The next problem says how many moles of sodium chloride can be produced when there are 21.3 moles of sodium. So we're using the same chemical equation here, and we know that it's already balanced, so I can proceed with my problem. All right, I'm going to figure out what is my given and what is my wanted. So given to me in this problem, it says that I have 21.3 moles of sodium. So this is going to be given, so this is the one given to me. So sodium is going to be my given substance. And then I'm trying to figure out how many moles of sodium chloride are being produced. So this is going to be my wanted substance. All right, once again, I'm going to go up to my balanced chemical equation and circle the two that I'm really comparing. All right, so I know, based on my balanced chemical equation, that 2 moles of Na can be set equal to 2 moles of NaCl. So remember that this is called that mole ratio conversion factor. All right, now I'm going to set up my dimensional analysis. So I know that I'm going to use this conversion factor within my dimensional analysis. Okay, so dimensional analysis, always going to put my given in the upper left-hand corner. So my given told me that I had 21.3 moles of sodium. All right, remember that this conversion factor is going to be in that next column. I want to get rid of moles of sodium because that's what I have up here. So the 2 moles of sodium from my conversion factor are going to go on the bottom, and then my 2 moles of NaCl are going to go on the top. All right, so if I cancel everything out, so I have moles of Na gone, I'm going to be left with moles of NaCl as my unit for my answer. All right, so you are probably already noticing that 2 divided by 2 is just going to be 1. So you're going to have the same amount of moles that you did for sodium when you actually solve this. You could also just do 21.3 times 2 divided by 2. You're going to get 21.3 moles of NaCl. Now you're probably wondering, well, Mrs. Tempest, why did I have to do all that work? The whole point of stoichiometry and dimensional analysis is to show me that you know how to cancel out units. So do you know the concept of units canceling? You could have probably done this in your head, but in your head, you can't show me that you're canceling out units. This is showing me that you started with moles of Na and you used the information given to you to convert to moles of NaCl. All right, so this is something that I have found very helpful for students as we work through stoichiometry problems. This is a stoichiometry flowchart, and basically it's like a finger pointy chart where you put your finger on where you're starting, and then you put your finger on where you want to go, and you got to figure out how to get there. All right, so at this point, we are only using the top half of this chart. So for our lesson for today, we went from moles of given to moles of wanted. This is the only part of this flowchart that we learned today. All right, now in order to get from moles of given to moles of wanted, we had to go through our mole ratio. And we found this mole ratio in our balanced chemical equation. Also, something to note is that when we did our dimensional analysis using this, we had something that looked like this. We put our given here, right? And then we put our conversion factor here. I like to refer to these in my dimensional analysis grid as columns. So this would be one column, and this would be the second column. So you're going to probably hear me referring to that a lot. All right. Notice that I have 2 columns for a mole-to-mole problem. And I also have 2 boxes that I'm going through on this flowchart. So that's going to actually come in handy. I will go through some more examples as we go from grams of given to moles of wanted, or moles of given to grams of wanted, and then finally grams of given to grams of wanted.